Hi, today's lesson is going to be on functions and methods. More specifically, what are functions and methods and how they can be used. In this lesson, we'll cover a function with no arguments and no return, a class method with one argument, a static method with one default argument, an object method that accepts a lambda, recursion generating factorials. All right, let's get started. Okay, so what we have here are the function that has the word DEF or the keyword DEF in the front of it, and the name of main, and it has a set of parentheses for a list of arguments, and then it ends the method declaration. And this is what we call our main function, and essentially it's a block of code that can be called somewhere else. So what you see here is the main function actually being called, so that when we run this, it'll show the hello live lessons because we're calling to the print function, then we're calling to the print function again with the string hello live lessons, and then we're calling to the print function one more time with an empty string. So let's see what that looks like. Okay, great. So we got hello live lessons. All right, so just to give a little bit more detail on what a function is and the different types of functions that there are roughly about 5 types of functions. One of them is just a basic function like this main function here. Another is a class method or functions and methods. Another is a class method where it's accessible as an instance method and also accessible as a somewhat of a static method where you can access it by using the class name instead of an instance. We'll see an example of that in a moment. And static methods. So static methods are functions that belong to the class, but you can actually access them by using the class name, and then you can say dot and then whatever the function name or the method name is in that case. We'll see an example of that. Object methods, we've dealt with that in the past with the shoe class in a previous lesson. And basically the shoe class had a method of set for running. And basically we set the running property to true in some cases. So lastly, we have lambda functions, where basically it's a small anonymous function. But going back to the basic function, let's look at an example of what a basic function looks like. So basically, we have the DEF keyword for all functions. This basically says we're defining a function. And then after the definition or the defining function keyword, we have the function name. So in the previous case, we had main. But this one is just name, just as a template, you can name it whatever you like. The arguments, in the case of the main that we just dealt with, it did not have any arguments, but we could have added arguments if we needed to. Also, the function body or the method body basically consists of everything after the function closes its definition, the first line of it. And indentation happens within the function because this is a block of code. So we start off the block of code with the DEF, and then after the DEF, we indent a tab, and then we start our execution statements inside. And lastly, the return value. So some functions do have returns and some functions don't return anything. So in the case of the main, back over here, we don't return anything, but we'll see an example of a function returning a value in just a moment. All right, so the first function that we are going to create is one similar to main, but it basically prints the name of its own function. And within it, we're just going to call print. And we are going to say called print's name. All right. And then we're going to do an extra print statement after that, just to make space on the screen so everything is clean and easy to read. All right. So let's call to that method. All right, so because it's just a function, it's not within a class, we can just call it directly. Similar to how we have print, we also have print's name now. Print's name, and that is the gist of it. Okay, great. So we have the printing of call print's name. So this is a basic function. It doesn't have any arguments, but at the end of the definition, it's here, and then basically we indent one tab within it, and then we, create our body where we have statements, different statements on each line. So the first statement is call print's name, and then the second statement is just printing an empty string. All right, moving along, we're going to get into class and static methods. Right, so let's go ahead and create a class called class and static methods. And within the body of the class, we're going to create a class method. And it's going to be a function, but it's going to actually be a method now because it's inside of a class. So we're going to call this one a method. All right, and we're also going to have another method by the name of print's name, and it's going to take the self as no, it's going to accept the class as a parameter, and within this function or method, we're going to use the print, and we're going to say hello. And we're going to interpolate a string, and we're going to use an accepted value of name. All right, and within this method, we're also going to print an extra statement here. We're going to create a new statement that's going to print an empty line. So basically, the way that we access this print's name class method is by referencing class and static methods dot print's name, and then we're going to pass it some John Doe name, right? And this should be tested. Okay, great. So what we do with the class method is basically declare it in like a static form, and we allow the class name dot print's name function or method to be called, and then we pass it a parameter or an argument, and then that argument is used inside of a print statement for hello and then whatever the name is. All right, so that is the print's name class method. We're also going to do a static method inside of the class and static methods class. And this static method is going to be called random integer. And it's going to accept a argument, but because we want to use this two different ways or more than one way, we're going to set the argument to 0 by default. And then within the function or within the method, we're going to return a value. So we need to bring into this Python script the import or the import for random. So let's go ahead and do that. And within the random integer method, we're going to say random dot randint, and we're going to have a range of numbers to give a random number within. So from 0 to 100, and yeah, let's run it this way first, and then we're going to use the offset parameter or argument after we run it at least once. So let's go ahead and create a variable by the name of random int, and we are going to call to the class and static methods dot random integer, and we're going to print that random integer, and we're going to interpolate a string, and we are going to take the random int value, and we're going to do one more print after that. All right, so let's go ahead and run this. Okay, yeah, so we got a random integer of 99 this time. Let's see what we get the next time. 79, it's going lower and lower. Okay, great. So now we're going to use the offset. So this offset is going to increase the range and also start the range or start the random numbers at this offset. So let's go ahead and add the offset here and add the offset here. All right. And because of the value of 0, when we don't pass, when we don't pass anything within the parentheses for the random integer, it uses 0. But we are going to create a random offset int, and with the random offset int, we will pass in the value of 50. So what this does is it goes from 0 to 150 when we pass in this value of 50, because it actually takes an actual value. So when we default a number here, we don't actually have to pass an argument here. All right, so when we pass in the 50, it goes from 0 to 150, and also it starts above 50. So essentially, when we get the random offset integers, they're pretty much going to always be more than the random integers by themselves. So let's go ahead and test that theory. Yeah, so we have 77, which is between 0 and 100. And then we have 119, which is between 0 and 150, or actually between 50 and 200, between 50 and 200, because the offset is of 150 added to the 50, so that's 200. Okay, all right, so moving along, we also have the, let's see, yeah, so now we're going to move into the object methods. The first one is going to accept a lambda. So let's go ahead and create the class for the mathematics class for the lambda and also the factorials. So class mathematics, and it's going to have a function called accepts lambda. And because it's not a class method nor a static method, it needs the reference for self, similar to what we did in the shoe class in our Python objects lesson. So basically, with this self, we get to reference all of the properties, if they exist, of this mathematics class and within a single instance of that class, or one single object of that class. All right, so let's go ahead and create the innards of this. So inside of the accepts lambda, we are going to print first, print, and we are going to have a lambda value, and we're going to interpolate a string. Sorry about the bird, if you can hear it. Also, we're going to have an argument that comes here, and we're going to call this anonymous or anon function. Basically, that's what a lambda is. And we are going to interpolate it, and we're going to call anonymous function with the value of 11. All right, what happened here? 2 parentheses. All right, a non-function accepts lambda. What's the problem? Oh, the comma. I keep doing that. All right. All right. Okay, so basically a lambda is a inline function declaration, and you can actually pass it around as if it's a variable or an object. It's basically an object because functions are objects, attributes are objects. Pretty much everything in Python is an object. So when we pass the anonymous function into accepts lambda, we pass that lambda a value, and then we return that value to show what the lambda value is. So let's go ahead and create an actual lambda. So here we need to create a lambda by the name of first lambda, and for it to work, we need to use the word lambda, and we're going to take whatever the parameter is, the input to the lambda, and we are going to say that is the function declaration of the lambda, is that it takes an input, and secondly, we need to have the return value of the lambda. So we have input, and basically we're going to multiply it by 5. All right, so essentially what we do here is we declare a variable argument for the lambda, and then we use that argument, and then we multiply it. So because it's a lambda, it knows that whatever the expression is on the right side of the colon is the return value. So basically it returns some number times 5 as the lambda. All right, so let's go ahead and create the mathematics instance. So mathematics, And it looks like this. And then basically, after we create the mathematics instance, we can say mathematics dot accepts lambda, and then we just pass in our first lambda. All right, so what happens here is this lambda that's been created has an input. It uses that input for multiplication, and then it returns the value. So when we come back here, our input is actually 11. So it says 11 times 5, and then that's what returns in this anonymous function or lambda value. All right, so that's what we'll see happen. All right, so let's go ahead and run this. Awesome. So 11 times 5 is 55. Okay, great. So moving along, the last function that we have is a little bit more complex. It's going to deal with a concept by the name of recursion. And essentially, recursion is like when you call a method and then it calls itself until you say stop. So our recursion method is going to be called factorial. And it's going to take a number and also the self argument. And there's two things to note about this. So the first thing is that it has a base case. Oops. As a base case. And the second thing of note is that it has trailing logic. All right. And also just for as a visual representation, let's go ahead and show what factorial is really doing behind the scenes. So imagine that we call factorial 5, and basically factorial 5 will call factorial 4, and so on and so on. So factorial 4 will call factorial 3, and factorial 3 will call factorial 2, factorial 2 will call factorial 1, and factorial 1 will call factorial 0. Okay, so this is essentially what is going to happen. Let's say that we call the factorial function with the number 5. Basically, it does that, and then there's a calculation that happens. It checks to see if it's the base case, but if it's not the base case, then it continues down and down and down. But to get from 5 to the next number, we actually subtract 1 from the number that comes in. And then we call factorial again on that new number, factorial again on that new number, factorial again on that new number, until we get to the base case. So the base case is 0. And essentially, we're going to say something like, if number equals 0, then do these things. And then outside of that if logic, we're going to do the calculation below it. So that will be the tail logic here. So let's show what that looks like. So our base case is going to be if number equals 0. And essentially, we need to do a couple of things. So the first thing we need to do is print the value. We're going to print the value of 1. But because typically when you use the print, it goes to a new line, and we want all of these values that are reported from the factorial to be in the same line, we need to type the keyword end. And this will work after we bring in another import. So let's go ahead and bring in the import for the print function. All right. Uh-oh. Oh, it has to be the first one. Yeah. We bring in the import for print function, and basically we're able to do this now without any problems. All right, so aside from that, we also need to return the final value. So whenever number equals 0 in a factorial, you can't take 0 and then multiply it by the next number that was above it, 1, and get anything else other than 0 all the way to the end. So factorials work by, when you get to the last digit counting, you multiply by 1. So 1 times 1 times 2 all the way up to the number that you call factorial. All right, so the tail logic will have a value and it'll have the number calculation. So value equals number times, oh, almost got that wrong, self dot factorial. And then we take in number minus 1. All right. And we're also going to do another print similar to what we did before, but this time we're going to use a comma and string interpolation, and we are going to interpolate the number, and we're also going to end the line with nothing. I guess I could use either one. All right, so we're going to end the line with nothing instead of ending it with a new line. Because normally when you use the print, it ends it this way. This is the default value, but now we're changing the default value. Okay, so there's a reason why I did this print after the factorial, because once it goes all the way down the chain of 5, 4, 3, 2, 1, 0, we actually want the numbers in order of them being multiplied from the beginning to the end. So that's actually going to be when it comes back. So we return 1 when we get to 0, as you see here. And then we multiply by the previous number that came, which was 1. So 1 times 1 in this case. So these two, 1 times 1, and then times 2 times 3 times 4 times 5. All right, so when we're returning, we actually return in the proper order of the numbers. So that is why I put the print after the calculation, or yeah, after the calculation. But if I put it before, then it would return 1, and then it would return 5, 4, 3, 2, 1. So that's not the order that I wanted. So lastly, the last thing that we want to do is return the value. All right, so this is our factorial method, and we're going to do 2 factorial examples. The first one is going to be factorial 5, and we are going to say mathematics.factorial 5 as the argument or parameter, and we're also going to print. And we're going to say factorial 5 equals, and then we're going to say percent s for interpolation, and percent and the fact 5. All right, and I need to print an extra print, and also, yeah, so let's go ahead and just run this first one, and then I'll walk back through the code again. Uh-oh. Yeah, I need one more print. All right. Okay, great. So the way factorial works is whatever the base case is, you return 1. So in this case, the base case is 0. And then you take the previous number and then you multiply the two of them. So 1 times 1 equals 1. And then 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. And 24 times 5 is 120. All right, so that's basically how factorial works. And essentially what we have is the number 5 coming in here. So 5 does not equal 0. And then it comes past this if logic. And then it says 5 times factorial, this same function, same method. And then we say 5 minus 1. So that's where we start at 5 and then we come to 4. And then we have 5 times 4, and then we call factorial again at 4. So 4, and then 3, and then 2, and then 1, and then 0. All right, so then we have 0 here, and then we have the 1 that prints. That's this guy. And then we return that 1. And then we have, we come out of the 0 base case, and we have this value of 1 multiplied by the previous number, which was also 1. So 1 times 1. So that's these two right here. And then, and then we come back all the way up to 5 in this case. All right, so that's why we get 120. All right, so let's go ahead and do one more factorial, and then we're going to take some questions. So 5, 10, 10, and all right. I believe this one is roughly about 3 million. Yeah. All right. So 3,628,800. Okay, great. So that is how factorial works. It basically just calls all the way down from the number that's passed to it to 0, but it returns a 1, and then it multiplies all of those numbers going all the way back to the number that was passed in. All right, so that was recursion generating factorials. Let's look to see if we have any questions now. All right. Okay, yes, it looks like we have a couple. All right, someone asked, what is the difference between methods and attributes? Well, basically, we don't have any attributes in this example, but attributes are basically like the nouns for your class, and methods are like the verbs for your class. So these are the things that you can take action on. So essentially, a variable is stored as an instance or stored in an instance, and or a class, and it's called an so it's basically the variables that get declared. But also a function or a method is stored in an instance or class, and it's called a method. So a method has a block of code, but a attribute is basically just a variable that changes value whenever you need to. Hopefully that answers your question. All right, we have another, while they are both objects, no. I've heard about declaring functions inside of functions. Can you do an example of that? Yeah, sure. Let's see. Let's go with this basic, no, this one right here. Okay, so yeah, it's definitely possible to declare a function within a function. It's kind of unique. I haven't seen it in any other programming language, but sometimes it serves its purpose. So let's go ahead and create we'll create a function called format reading, right? And this, you might want to notice that this is a function similar to a regular function without it being inside of a class. I'm not going to pass any self or any class or anything inside of here. And basically what we're going to do is return a format. So let's take this format here and put this there. And we should also accept some kind of text as the argument to format greeting. And we have hello string interpolation of placeholder. And then we're going to call this function here. So we're going to say format greeting. And we're going to pass in the name to the format greeting. All right, so this is an example of a method that has a function declaration inside of it. And basically, we call it format greeting. And then we have hello %s, and we take some placeholder. And then within the scope of this function, this placeholder exists. But out here, this placeholder does not exist. So we basically have the format greeting, and then we pass the name, which becomes placeholder in this situation. All right, so let's go ahead and run this, and it should basically print out hello, John now. Or actually, hello, John, how are you? All right, let's go ahead and do that. Yeah, there we go. So we have hello, John, how are you as the format greeting. All right. Let's see if we have any more. No, looks like we do not have any more questions. Okay, so our next lesson is supposed to be on Python loops. We'll talk about for and do and, you know, all of these different types of loops that exist and, you know, do some special things with them. Lastly, if you want to make a lesson suggestion, maybe I didn't answer your question here because it wasn't about methods or functions, but maybe your question is about Python files, Python networking, you know, using API calls or database calls or something of that nature. Take a moment and go to git.io/J lowercase q F 3 and D. That will show the lesson suggestions, and then you could make a comment there and we'll update them when we get around to actually needing to fill in the lessons when we run out of lessons. So our next lesson is Python loops, and I look forward to seeing you guys there as well. Have a good night.